Green Chemistry Overview. Green chemistry, also known as sustainable chemistry, is an approach to designing products, processes, and systems that minimize the use and generation of hazardous substances. It aims to reduce the environmental impact of chemical processes and products by promoting the use of safer chemicals, minimizing waste, and improving energy efficiency. The principles of green chemistry prioritize the well-being of both humans and the environment. Key principles of green chemistry. Prevention. Design processes to prevent the formation of hazardous substances, rather than treating or disposing of them after they are formed. Atom economy. Maximize the incorporation of all materials used in a process into the final product, minimizing waste and byproducts. Safer chemicals. Design and use chemicals that are less toxic to human health and the environment, without sacrificing functionality. Design for energy efficiency. Optimize energy use in chemical processes to minimize the environmental impact associated with energy consumption. Renewable feedstocks. Use renewable raw materials whenever possible to reduce reliance on non-renewable resources. Reduce derivatives. Minimize the use of derivatives, such as blocking and protecting groups, that can generate waste and have associated environmental impacts. Catalysis. Use catalytic processes to increase the efficiency of chemical reactions, reducing the need for high temperatures and pressures. Design for degradation. Design chemical products to break down into innocuous substances after their useful life, reducing environmental persistence. Real-time analysis. Develop and use real-time analytical methods to monitor and control chemical processes, minimizing the risk of hazardous substance formation. Safer solvents and auxiliaries. Select solvents and auxiliary substances that are safer and have minimal environmental impact. Implementing sustainable practices. 1. Assess current processes. Evaluate existing chemical processes to identify areas for improvement. Assess the environmental impact, resource use, and waste generation associated with each process. 2. Education and training. Educate personnel about the principles of green chemistry and sustainable practices. Training programs can enhance awareness and foster a culture of sustainability within an organization. 3. Substitution of hazardous chemicals. Identify and replace hazardous chemicals with safer alternatives. Consider the toxicity, bioaccumulation potential, and environmental persistence of chemicals used in processes. 4. Waste minimization. Implement strategies to minimize waste generation. This may include optimizing reaction conditions, recycling byproducts, and exploring alternative reaction pathways. 5. Energy efficiency. Optimize energy use in chemical processes. Consider alternative reaction conditions, such as lower temperatures and pressures, and explore energy-efficient technologies. 6. Life cycle assessment, LCA. Conduct life cycle assessments to evaluate the environmental impact of a product or process from raw material extraction to disposal. This holistic approach helps identify areas for improvement. 7. Sustainable product design. Design products with sustainability in mind. Consider factors such as recyclability, biodegradability, and the use of renewable materials in product design. 8. Collaborate and share best practices. Collaborate with industry peers, research institutions, and regulatory bodies to share best practices and collectively work towards sustainable solutions. Participate in industry-wide initiatives and certifications. 9. Regulatory compliance. Stay informed about and comply with environmental regulations and standards. Many regions have regulations that encourage or require the adoption of green chemistry principles. 10. Continuous improvement. Establish a continuous improvement mindset. Regularly review and reassess processes, products, and practices to identify opportunities for further sustainability improvements. By incorporating green chemistry principles and sustainable practices, industries and researchers contribute to a more environmentally friendly and sustainable future. The implementation of these principles not only benefits the environment but also enhances the efficiency and competitiveness of chemical processes and products.